Okay, so in this class I want to uh, investigate the probabilities for an experiment involving 3 tasks. Remember, to find the probability of any event, it's the number of ways that event may occur divided by the total number of possible outcomes. That's central to everything. Suppose I have this experiment. Task 1 is to spin the first spinner, task 2 is to flip the coin, task 3 is to spin the second spinner, and I want to investigate the possible outcomes from this experiment. I can draw a tree diagram. I cannot draw a two-way table because it's not 2 tasks. There's more than 2 tasks. A two-way table will not work. So I'm going to draw a three-way. Going to draw a tree diagram. And if I look at the first task, which is to spin the spinner, there are 3 possible outcomes from that first task. And those 3 outcomes are called 1, 3, and 5. Now if we just start to think about the probabilities and include the probabilities in the tree diagram here, the probability that I spin the spinner and it lands on 1, remember what a spinner is. Let me see if I can kind of model this spinner. So if I get this spinner, we're just spinning it around and it goes around and around and around. Okay, and it will land in one of those 3 circle sectors. The probability that it will land in 1, well, each one has an equal area, an equal central angle, so the probability that it will land in 1 is exactly 1 in 3. The probability that it will land in sector 3 here is also exactly 1 in 3, and the probability that it will land in sector 5 is also 1 in 3. Notice the sum of those 3 numbers is 1. The second level of my tree diagram will involve looking at the second task, which is to flip a coin. Given that 1 was the outcome on the first task, the possible outcomes when I flip a coin are heads and tails. And if 3 had been the outcome on the first task, well, that doesn't really affect the possible outcomes. They're still heads and tails. And 5 could have been the outcome on the first task. We'd still have possibility of heads and tails. And again, if we just think about that, the probability of flipping the coin and it landing on heads is 1/2, and the probability of it landing on tails is 1/2. Notice they combine to give me 1. And those probabilities are not changed. The probability, given that 3 happened in the first task, and 3 was my outcome from my first task, the probability of heads in my second task is still 1/2. The probability of tails in my second task is still 1/2. And if 5 had been the outcome of the first task, the probability of getting heads on the flip of the coin is 1 and 2. The probability of tails is 1 and 2. Notice each little collection of branches adds up to 1. 1/2 plus 1/2, 1. 1/2 plus 1/2, 1. A third plus a third plus a third, 1. So there's 2 tasks complete. And then finally I have to complete the final task, which is to spin this second spinner over here. So again, remember, we just spin the spinner, it goes around and around and around until it eventually stops. And the angles are the same here. They each have a 180-degree angle at the center, so you're equally as likely to land on blue as red. I want to fill in my third level of my tree diagram. Well, if we had got 1 on the first, heads on the second, then the possible outcomes for the third one are red or blue. And that doesn't matter. If it had been 1 and then tails, the possible outcomes for the third one are still red and blue. And I hope you can see that red and blue, no matter what has happened before, red and blue are still my possible outcomes for my final task. And again, important thing to note is that, it doesn't matter what has come before. No matter what has happened previously, the probability of getting red on the last task is 1/2, and the probability of getting blue on the last task is 1/2. So what has come before does not affect the probabilities for this task. Okay. And one thing I can do, which is a multiplication rule, which we will revisit, but if I want to find the probability of getting 1 on the first, and then tails on the flip of the coin, and then blue on my third task, so 1 on my first task, tails on my second, blue on my third. Well, what we can do is we can just multiply 1/3 times 1/2. So it's 1/3 is the probability for getting a 1 on the first, times 1/2 is the probability of getting a tails on the second, times 1/2 is the probability of getting a blue on the third, and what we're getting there is 1 out of 12. And that's a useful thing to know. Okay, to find the probability of some event A happening and then B happening. Well, that's the probability of A happening multiplied by the probability of B happening given that A has already happened. Okay, but we can draw a tree diagram, multiply the probabilities along the branches to find the probability of the event in which you are interested. Okay, so that's looking at experiments involving 3 tasks.